Hello, this video is for IXL Activity A1.A.11 titled Classify Numbers. The 3-character code for this activity is Romeo Bravo 8. So classifying numbers. Well, numbers are like a lot of things, like rocks and animals. They can be classified. In science, you talk about the classification of rocks. We could classify the elements in the periodic table. We could also classify the classification of living organisms, animals, and so forth. And we're also going to talk about the classification of numbers. Or I should say, we're only going to talk about the classification of numbers. The other ones, well, that would be science class. So we're going to talk about real numbers. And other than real numbers, the only other numbers are imaginary numbers. And we're going to be coming across any imaginary numbers. So in this activity, whenever they ask you if it's a real number, the answer is going to always be yes. That number is indeed a real number because, well, we're not going to see any imaginary numbers. So I have this graphic organizer here, and the idea is that if it's inside of the circle, then it belongs to that group. So we have the set of real numbers, and then we've got some subsets. Starting on the inside at the very middle here, we have natural numbers, and it's represented with the letter N. We have whole numbers, represented with the letter W. We have integers, represented with the letters Z, and rational numbers that are represented with the letter Q. And then over here in a section all by themselves are the idea of rational numbers, and those are represented with the letter P. So let's go ahead and first start inside here at the very inner circle with natural numbers. These are the numbers that you learn first naturally. Whenever you're a small child, you learn to count by 1, 2, 3, 4, 5, etc. So those are the first letters that you learn, or first numbers that you learn, and you, well, naturally that'd be the first thing that you would be taught as a child, because, well, it's how many toes and how many fingers you have. So it's all the positive non-decimal numbers. The next group out is whole numbers. Now the only additional element of whole numbers that is not part of natural numbers is the number 0. So in 0, well, 0 looks like a whole, H-O-L-E, so the only addition to natural numbers to get the whole numbers is 0. So all of the whole numbers are 0 along with all the natural numbers, 1, 2, 3, 4, 5, 6, 7, etc. It's a positive infinity, right? Next we get to integers. By definition, integers are all the whole numbers and their opposites. So it's all the non-decimal numbers that are negative. So such as -1, -7, -4, -29, -1,233. Those are all examples of integers. Now, also, along with the integers also include the whole numbers, the number 0, and all of the positive non-decimal numbers such as 1, 2, 3, 4, 5, 6, etc. Then as we continue out, we get to rational numbers. These are numbers that would form decimals if we were to simplify them in some way. For instance, 1/2 would simplify to 0.5, so that would be a decimal number. We see 0.36 here, that's a decimal number. 7/5 would simplify as a mixed number, would be what? 1 2/5. So if we make that a decimal number, that would be what would that be, 4, right? So that's a decimal number. -3/22. If we divided 3 by 22, we would get a decimal number there as well. The thing about rational numbers are they're decimal numbers, but so are irrational numbers. Those are decimal numbers also. However, the difference between a rational number and an irrational number is that rational numbers have decimals that either terminate or they repeat, such as 1/4. We write 1/4 as 0.25. And it would just stop there. There's no number that comes after the 5. If we had a number like 1/3, if you write 1/3 as a decimal, it would be 0.66666, so it would be a repeating 6. So here we could have a repeating decimal, or we could have a terminating decimal. These would be examples of rational numbers. Then finally, let's have a discussion about irrational numbers. Irrational numbers are decimal numbers that do not repeat. For instance, the value of pi. If you put pi into a calculator and hit enter, it should give you the number of 3.1415 2, 6, 2, 6, 5, 4, and it would just keep going and going. Notice it doesn't have a repeating pattern, and it doesn't terminate. Also, if I take the square root of 2, that would give us a value of 1.414213562. And it would just keep going. Notice it doesn't terminate and it doesn't repeat. Also, if I do the square root of 17, that's going to give us a value of 4.123105626. And that's, the calculator doesn't have any more room to show those numbers, but you can see there's no repeating pattern and they do not terminate. It means they do not end. And then this value of E, if you find it on your calculator and enter it in, it's going to produce a number of 2.7182818281828. Now it does look like there's a repeating pattern there, but if you had a calculator that could handle it, it would show, you would realize that there's not. It looks like this 1828 is repeating, but in all actuality, it's not. So if you do come across that E in this activity, that would be a irrational number. However, I don't believe that you will. So real quick, before we move on, let's revisit this concept of what we see over on the left side here of rational numbers. You see, all natural numbers are also whole numbers, integers, and rational numbers. If it's on the inside, it also belongs to everything on the outside. Whole numbers, likewise, are not only are they whole numbers, but they're also integers, they're also rational numbers, and they're also real numbers. Integers themselves can be integers, rational numbers, or real numbers. However, we have some integers that are natural numbers, like 2, 3, 4, 5. Notice that 2 and 3 and 4 and 5 would be here in natural numbers, and that's also inside of the integer circle. However, not all integers are whole numbers, such as -7, -4, and -1. So again, the idea is that if it's inside of the circle here, then it belongs to that group. But if it's outside of the circle, it may not belong to the group. And we'll have plenty of discussion on that, and hopefully that'll become pretty clear. So I've included this graphic organizer in all of these slides so we can kind of work our way through it. I strongly encourage you to find a graphic organizer like this. If you just type in classification and numbers on a web search and go to images, you'll find a lot of different graphic organizers showing the classification of numbers. So which of the following best describes 0? Select all that apply. So we see that 0 is right here and shows up first inside of the whole numbers. So 0 is a whole number, it's an integer, it's a rational number, and it's real. So let's look and see which ones are there. Real numbers, yep, good to go. Irrational, notice 0 is not over here, so we're not going to select this. Is it a whole number? Yes, indeed it is. And is it an integer? We also have integer underlined as well. On the next example, which of the following is an integer? So we're looking for non-decimal negative numbers. So on this case here, looking at that, we see that what about square root of 2? Well, we see square root of 2 over here. That's over an irrational number, so it can't be an integer. 2.666 repeating 6. All right, so that would be a decimal number. And notice that decimals are not inside of the integer group here because they're outside of the integer circle, so we'd rule this out. 7/6, well, this is going to equal, what, 1 1/6? So we realize that if we were to simplify this, it would result in a decimal number. So decimal numbers can't be an integer, so we would rule this one out. What about 9? Where would 9 go? Well, 9's a natural number, right? So 9 could be a natural number, whole number, integer, rational, and real. So does 9 belong to the group of integers? Well, indeed, we have it underlined, so we'll say yes, it does. How about 4/9? Is this a natural number? Well, 4/9, if we simplified 4 divided by 9, we would get a decimal number, right? Decimal, there we go. So decimal numbers are rational numbers. And the question is it a repeating decimal? Well, we really don't have to worry about that because they're asking, is it a natural number? Well, notice that 4/9, if we put it out here, and if we did 4 divided by 9, 4 divided by 9, it would be a repeating 4. So this equals 0.4 repeating. So it doesn't belong to rational numbers. However, they want to know, is it a natural number? So 4/9 would be a rational number and a real number, but notice it's not inside of natural numbers down here, right? So in that case, we would say, no, it is not a natural number. How about 37/45? Well, let's take 37/45. Let's turn that into a decimal. 37 divided by 45 is going to give me 0.82 repeating. So it is a repeating decimal. So in that case, it would belong in here, 37/45. So it's a rational and real. But they want to know, is it irrational? Well, irrational is over here, right? So it can't be over here and over there. So it has to be just rational, not irrational. Which of the following best describes 7 repeating 4? 7-point repeating 4. So that would be here, right? 7-point repeating 4. Decimals that repeat are rational numbers. So 7.4 repeating would be rational and real. So we're only going to pick rational or real. Here we see rational number. Here we see real number. It's not irrational. It would have to be over there. And it's not a natural number because it's outside of the natural number circle. Which of the following is an irrational number? Well, we're going to have to do a little bit of work here. Let's see. Square root, absolute value of the square root of 1. Well, let's first talk about the absolute value of square root of 1. Well, square root of 1 is 1, right? And then the absolute value of 1 is equal to 1. 1 would be a natural number. So we're talking about irrational, just these numbers over here, right? We're wanting the stuff that belongs over here. Well, we see that the absolute value of the square root of 1 turns out to be 1. Well, that would be here in natural numbers. So we could rule this one out. Square root of 0, well, we did that in square root activity that we did. Square root of 0 equals 0. So it shows up 0 is a whole number, integer, rational, and real. But it is not an irrational number. So we can rule this one out. What about pi? Well, we see pi show up right here, right? It's actually listed in the list of irrational numbers that we have for examples. So this one here we would select. And then 4/1, well, 4 divided by 1 is 4, right? Any number over 1 is equal to itself. So 4/1 equals 4. That would be natural, whole, integer, rational, and real. But it would not be irrational. So our only correct answer is pi. Which of the following is a whole number? So this time we're looking for whole numbers. Well, whole numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the positive non-decimals, along with 0. So we're looking for 0, 1, 2, 3, 4, etc. Well, this is a decimal number, so we'll rule that out. That belongs out here with rational numbers, or irrational it could be. But it does end. Notice if it had ... we know that it continued. But since the ellipses, that's what we call those 3 dots, is not there, we know that this would be a terminating decimal, so it would be rational and real, but not whole. What about the square root of 0.28? Well, I could check that on the calculator, square root of 0.28. I don't think it's going to be. It's actually a decimal number, and it's non-repeating, so it's actually irrational on this one here. So that's an irrational number, so it's not a whole number. The absolute value of pi is pi, so that's going to be that 3.14 and a bunch of numbers, so we can get rid of that. What about the square root of 1/1? Well, this equals the square root of 1/1 is equal to 1, and the square root of 1 is 1, so is the number 1 a whole number? Well, we see that number 1's here, so that means it's natural, whole, integer, rational, and real. So is it a whole number? Indeed, it is a member of the whole numbers. Which of the following are whole numbers? So there could be more than one correct answer. So let's go through each of them. This is the opposite of the square root of 4. So the square root of 4 is 2, and the opposite of 2 is -2. So what about -2? Well, that would be integer, rational, and real. So it's not a whole number, so we'll get rid of that. Let's look at the next one. We have 9/9. Well, any number over itself is equal to 1. And the square root of 1 is 1, so we're talking about this value here. So it's natural, whole, integer, rational, real. So is it a whole number? Indeed, it is in that whole number set. So we would count this as a correct answer. On the next one, 1/5. Well, 1/5 is going to simplify to 0.2. Well, so that would be out here, 0.2. So that would just be rational and real. So it is not a whole number. Rule that one out. And then finally, for our last number that they give us, we have 2 over 1. Any number over itself is equal to itself. Or we could say 2 divided by 1 is 2. So we're talking about this number here. So that's natural, whole, integer, rational, and real. Is it a whole number? Indeed, we do see that it's inside of the whole number circle. So this would also be a correct answer. Let's look at our next question. Which of the following describes the value of 3? Select all that apply. So we see here's 3 right here on our chart, right? So 3 is a natural, whole, integer, rational, and real. So any of these that we see in the list of answers, we're going to go ahead and select those. So irrational, nope, that's over here, so we can rule that out. Real number, yes. Integer, yes. And natural number, yes. 3 is all 3 of these, real, integer, and natural. Final question, which of the following is a rational number? So let's go ahead and start off with this, the absolute value of the square root of 0.95. So let's go ahead and take that square root of 0.95. So the square root of 0.95 is going to give us a value of, well, that's a decimal number. It's a really long one. It's not, see, it looks like it doesn't terminate. So it's going to be 0.97467. It's going to keep going. And the absolute value of this is that value itself. So just positive. If you're not familiar with absolute values, whatever's in between the absolute value sign, it's the same value, only it's positive. So if it's positive, it comes out and stays positive. If it's negative, it stays negative. Kind of real quick here, just in case you're not familiar with absolute values. We have the absolute value of x, it equals x. And the absolute value of negative x equals x. So the idea is it all has to do with the distance from 0 on a number line. That's what absolute value is all about. We'll talk about that in another lesson. But for now, just understand that whatever's inside the absolute value sign comes out. If it's positive, it stays positive, same value. If it's negative, it comes out. It's just the same value, only it's its opposite. It's going to be positive form of whatever the value of x is. So this would be irrational over here. So we could rule this one out. On the next one, -1 and 4/6. So -1 and then 4/6. If I put it into a calculator, that's going to be the same as what that's equivalent to 2/3. And I know that my fractions well enough that that's going to be a repeating 6. So that's going to be -1 repeating 6. And the reason that we put it over with rational numbers is because that it does have a repeating pattern to it. It would be -1.666666, etc. So it's rational and it's real. So is it rational? Indeed it is. We'll select that. The next one, square root of 10. So on my calculator, I'm going to do square root of 10. And indeed, it's going to produce a 3.162277766. All right. So it's just going to keep going and going and going. So that's irrational. So we would not select that. It's over here with the irrational numbers. And then the absolute value of the square root of 2 is going to be the square root of 2. Okay, so that's kind of an example of what I was talking about. What's inside the square root, or what's inside the absolute value signs? Square root of 2. So what comes out of it? Positive square root of 2, which we see right here. So square root of 2 is an irrational number, and we're looking for rational. So we'd rule this one out also. So the second one is our only correct choice. So those are all of my examples for IXL A1.A.11 classifying numbers. Remember, use the chart or find a chart that you can use that's similar to this. There's several of them out there. And just kind of figure out where does it belong inside the chart. And then figure out, does it fall into those certain categories? And then select your answers from there. Good luck with your activity.